Welcome. Today's topic is 2D array and dynamic memory. So there are a couple of ways you can actually create a 2D array or say matrix in C. So the normal way to declare an integer, for example, we are using integer 2D array or integer matrix is like int a, then number of rows, number of columns, and then we can initialize. So you can see there are two ways to declare as well as initialize integer array. So take the first one, that is int a3 comma 3, that means 3 rows and 3 columns. So compiler will take first 3 elements as the first row, second 3 elements as the second row, and the last 3 elements as the last row or the third row. Now suppose by mistake or intentionally if you miss an element, that means the array size is 3 cross 3, total 9 elements are expected, but you have only 8 elements, then the very first 8 elements will be filled up by these elements 1 2 3 4 5 6 7 and 9, and the last element will contain garbage. Similarly, if you go for the second form of or second syntax form of variable integer 2D array declaration initialization, so 3 cross 3 again it tells compiler to create an array of a 2D array of 3 rows and 3 columns, but in this case you are using another second bracket or curly brace to instruct the compiler take this content within the second brace as the first row. So this will be first row, this will be second row, and this will be third row. Now suppose again if you somehow miss or uh, you do not give the 3 elements, instead you have given only 2 elements, so then the first 3 elements will be there, but in case of the second row, the third element, second row of the third element, so if you imagine this is your array A, so this is 1 2, this is 3, this is 4, this is 5, this is 6 7 8 and 9. If you go by this rule, then as there are only 8 elements out of 9, so the last element contains garbage value and this will be 9. But in case of the second one, like this one, 1 2 3, this will be as it is because within this brace, then 4 6, so it will be 4 6 and garbage, and then 7 8 9. So this is the static way of 2D integer array declaration, but our topic is how we can create a 2D array using dynamic memory allocation, that is using either malloc or calloc. Okay, so we'll see. So now this is the first way we will discuss by which we can using dynamic memory allocation, that is malloc function, and of course for malloc we require stdlib.h library function, and I haven't shown the whole programming, that is starting from has include, rather our focus here is only the concept, the real concept. Okay, so here what happens, so whenever we say a 2D array, that means it is a nothing but a matrix. It can be symmetric or asymmetric kind of thing, like means square matrix or non-square matrix. and we have taken few parameters, integer variables like r. C, r stands for row, 3 number of rows. C can be 3 number of columns. Okay, a pointer, a count variable, just for sake of easy assigning value. Okay, then p, this is very important, this whole statement. We have already discussed this in your previous video. P equal to in star malloc r into c into size of it. If you remember my last video, you have seen that the malloc always takes one argument within this parameter, only one argument, and that one argument is actually size, that is number of elements you want to allocate and the size of each element. So that is given by size of int operator, and r into c gives you the total chunk. So here, instead of uh, visualize the array in terms of a 2D array or kind of a matrix, actually what happens due to this malloc r into c into size of int, and as it takes r into c into size of int in a single single parameter, single argument, so it will create uh, a memory of r into c. Okay, so how the chunk is, so what will be the size of this malloc? It will be 2 if you assume this as per NCC 99 standard integer mean 2 bytes, so it will be 2rc. So this will be this many bytes, and obviously as always an index start from 0, so the last index will be r into c minus 1. And if the address of the starting element of that 2rc bytes, theoretically you can assume as 100, then obviously the subsequent element address location will be 100 to 104. It is already shown here. Okay, where r, these are the number of rows and these are the number of columns, but it will not look like this because it is r into c into size of it. It is so 2D array. It is a theoretical, it is a technically a 2D array, or you can say rather theoretically a 2D array, but it will represent inside the memory as a one dimension 1D array, but it will be created using malloc at runtime. Okay, so you can also use scanf statement for read this r and c, and using that this 2rc bytes of memory will be allocated at runtime. And then this is very important, how can you access, how can you assign some value to this each of the element. This is the value matrix, that means each of the, now the value is assigned, so count is always started is initially 0, but now based on this loop it always start with plus count. So first it is 1, then 2, then 3 subsequently, and how many times this loop will run. Now this loop will be executed for rc times. Okay, and for this rc times what will happen, p, so this will give always the very first, this will give you the 100, the base address, that is the address of the first element of the 2rc bytes of memory. Then I gives you the number of rows. This gives you, this is very important, it gives you the number of row, that means 0th first row, then 1 means second row, 2 means third row, and then plus j for each of the element. So if you suppose, if you want to think about this one, so for this value will be p plus I, then I will be obviously 1 because this is 0, this is 1, and this is 2, this is I value. And if you think about j, so this is 0, this is 1, and this is 2. So what will happen, this is 1 and this is r, so r value is actually 3, and then plus j, so this is j1. Okay, so we are looking at this particular value. So here the I is 1 and j is 1 also. Okay, so for that it will be 1. So let's check. So 3 into 1, that means 3, and 3 into 1 plus 1, that is 4. So 100 plus 4 into 2. So why I have multiplied this 4, 3 into 1 plus 1, it gives you 4, and in multiplied with 2 because integer means 2 bytes. In our previous videos we have discussed this part. So 100 plus, this is the P base address, plus 4 into 2. 4 comes from this very expression, and 2. So if you can see this, yes, this is 108, and it also gives you 108. So we are in correct way, correct direction or correct path. Now yes, again if you want to print these values using again the dereferencing technique, but remember why this expression looks something different from our previous videos or previous concept, because here it is a theoretically 2D array or 2D array or a matrix, but it is represented in a one dimension way in memory. So memory allocated what C bytes allocated in one dimension fashion. So that's why you have to use this expression P plus I into R. R stands for number of rows, I is the ith row, indicate the ith row, and J stands for jth column. Okay, so this is one of the way how you can actually create a 2D integer array. Okay.